The cursor tracking subsystem maintains a continuous record of pointer position within the document coordinate space. Position data is stored as a two-dimensional vector with floating point precision. Updates occur at regular intervals determined by the input polling frequency. The system maintains separate tracking for logical document position and physical screen coordinates. These coordinate spaces interact through the viewport transformation matrix. Position updates are queued in a circular buffer of fixed capacity. When the buffer reaches maximum occupancy, the oldest entry is discarded and replaced with the newest position sample. The default buffer size is 256 entries, accommodating approximately 4 seconds of position history at standard polling rates. Buffer entries contain timestamp, absolute position, delta from previous position, and velocity vector. The viewport transformation pipeline converts between three coordinate systems: device screen coordinates, window relative coordinates, and document space coordinates. Each conversion involves matrix multiplication with the applicable transformation matrix. The transformation matrices are updated whenever the viewport dimensions change, the document is scrolled, or the zoom level is modified. Transformations use homogeneous coordinates to handle translation and scaling uniformly. Cursor velocity is computed from successive position samples using a sliding window average. The window size is configurable and defaults to 5 samples. Velocity vectors are expressed in units per millisecond. When velocity magnitude exceeds a defined threshold, the cursor is considered in motion. This classification determines whether certain optimization techniques are applied during rendering. The hit zone detection system identifies which document elements fall within a specified radius of the current cursor position. Hit zone queries are expensive operations and are therefore performed only when the cursor exits one defined region and enters another. Hit zone radius defaults to 8 pixels in screen space, but scales with zoom level to maintain consistent document space coverage. Hit zone query results are cached in a lookup table indexed by hit zone identifier. Cache entries remain valid until the next hit zone transition event. When the hit zone changes, the old cache entry is invalidated and a new query is submitted to the element tree. The caching mechanism reduces per frame computational load during stationary cursor periods. Synchronization between local cursor state and remote peer state occurs through a gossip protocol. Position updates are batched into packets containing the current position, timestamp, and sequence number. Packets are transmitted at a configurable rate, defaulting to every 100 milliseconds. Out-of-order packets are discarded. Duplicate packets are identified by sequence number and ignored. Remote cursor positions are maintained in a separate tracking structure distinct from the local cursor. Remote cursors are rendered with reduced opacity and include a label displaying the associated user identifier. Remote position updates are interpolated between received samples using linear interpolation. Interpolation occurs at the rendering frame rate, providing smooth apparent motion between discrete updates. The cursor trail feature maintains a history of recent cursor positions rendered as fading dots. Trail dots are generated at fixed distance intervals along the path traveled. Each dot includes an opacity value that decreases exponentially with age. Trail rendering is disabled by default but can be enabled through configuration. Maximum trail length is bounded at 100 dots to prevent excessive drawing overhead. Cursor shape changes are driven by the currently active hit zone element. Each element type defines a preferred cursor shape identifier. Shape identifiers are mapped to platform-specific cursor resources through a lookup table. Shape transitions include a brief fade animation of 50 milliseconds by default. Rapid transitions that occur within this window are coalesced into a single animated change. Click event generation occurs when the input device reports a button press while a valid position is available. Click events include the position, timestamp, button identifier, and modifier key state. Double-click detection counts consecutive click events within a 300 millisecond window at substantially the same position. Position tolerance for double-click matching is 5 pixels by default. The cursor confinement system restricts cursor movement to a defined rectangular region. When the cursor approaches a confinement boundary, subsequent position updates are clamped to remain within the boundary. Confinement regions can be nested. The innermost applicable region is always used. Region changes take effect immediately without any transition period. Input event handlers are invoked in priority order based on their registration sequence and assigned priority level. Handler execution is synchronous and serial. Handlers may consume events to prevent propagation to subsequent handlers. Unconsumed events continue to the next registered handler. A handler's return value indicates consumption status. Exceptions thrown within handlers are caught and logged without propagating. Cursor state serialization produces a JSON representation containing the current position, velocity, hit zone identifier, and cursor shape. Serialization is used for session persistence and checkpoint snapshots. The serialized format is version tagged to accommodate future schema changes. Deserialization validates all fields and applies defaults for missing optional fields. Performance monitoring collects metrics on position update latency, hit zone query time, and synchronization overhead. Metrics are recorded in a circular buffer with 1-minute granularity. Moving averages are computed over 5-minute and 30-minute windows. Latency exceeding 50 milliseconds triggers diagnostic logging. Metrics are exported through the standard metrics export interface. The cursor tracking system shuts down through an orderly deactivation sequence. Active event handlers are notified of pending shutdown. Pending synchronization packets are flushed. The circular buffer is cleared and all allocated resources are released. Deactivation completes within 100 milliseconds under normal conditions. Forced shutdown occurs if graceful shutdown exceeds the timeout threshold.